Hello everyone, this is a very nice geometry problem from the Pre Regional Mathematics Olympiad 2019. It's from India, an Indian Olympiad, and it's problem 29 of that sequence. And it starts very interesting, in a very interesting manner. We start with a triangle ABC, and it's given that the angle bisector and the median are perpendicular to each other. That doesn't happen every day, right? So the median AD and the angle bisector BE are perpendicular to each other. And you can guess that I have drawn this picture before, because if you start drawing it for the first time, the angle bisector and the median are no way perpendicular to each other. So yeah, this is a funny little way you can draw it. Yeah, you can draw this using a little bit of trial and error. There is also a trick to draw it exactly. So this is also a construction problem. How can you construct such a triangle where the median and the angle bisector are perpendicular to each other? So these two angles are equal because BE is the angle bisector. That's given. BE is angle bisector. And it's also given that the length of BE is 9. That's given. And similarly, AD is median, and its length is 7. Okay. So this is the information given, and we are interested to find out the area of triangle ABC, or the actual problem said that we find the integer closest to the area of this triangle. Okay. Great. So the first thing first, you can pause this video and try to find out two triangles which are congruent to each other in this particular picture. Okay, that's the first hint. Okay, and you can do this readily if you observe that these two angles are 90 degrees, because it's given that BE is perpendicular to AD. This is also given. Suppose this point is M. So all these three data is given to us, and our goal is to find out area of triangle ABC. Okay, fine. So let's suppose the point of intersection is M. Now notice that these two angles are 90 degrees. These two angles are equal because BE is the angle bisector, and this side is common. So you can easily see that these two triangles, triangle ABM and triangle BDM, are in fact congruent. Okay, great. So if these two triangles are congruent, then these two angles are equal, these two sides are equal. That's because those two triangles are congruent. All right, let's do a little construction and join DE. So join DE. Can you pause the video now and get it done, get this problem done? It's not very hard from here. Okay, so once you join DE, you can easily see that, let's use the color yellow. These two angles are equal, these two sides are equal. That's coming from the previous set of triangles, and this side is common. So again, we have triangle AME being congruent to DME. So maybe I can shade the two triangles and you can easily see. Still have to see the letter M, so it's there. Okay. So those two triangles are congruent. In fact, you can now see that ABDE is a kite. Well, these two sides were equal, and now we know that these two sides are equal. So that's what a kite is all about. Anyway, we can find the area of this ABDE very easily. But how can we do that? Well, first, notice that we already know the length of AM. What is AM? AM is exactly half of AD, right? Because, well, AM is equal to DM, so AM is half of AD. And AD we know is 7. That's given, so that's 3.5. AM is 3.5. All right. And now we also know BE because BE is 9. That's given. So we know the area of triangle ABE. We know the area of triangle ABE. Let's do that. Let's compute it. So triangle ABE is half times base is BE, which is 9, times this is 3.5. 3.5 is the height. This is BE and this is AM. Perfect. Maybe I can do the write the M in red. Okay. So 9 times 3.5 times half, of course, that's the area of triangle ABE, and that is in fact the area of triangle, let's call this point D. Okay, so triangle BDE, because of course ADE, ABE and ABDE are congruent triangles, and congruent triangles will have equal area. Okay, that's great. So we have area of ABE, we have the area of BDE, and we also have the area of CDE. Why? Let me shade this. Why do we have the area of CDE? Well, look into this. D is the midpoint of BC. So if you look at triangle BEC, BDE and CDE must be equal because ED is the median of that triangle. So because median divides the triangle into two equal parts, the bases are equal, BD and CD are equal, height is same, so areas will be same. So we have the area of triangle CDE, we have the area of triangle BDE, and we also have the area of triangle ABE, and all of them are equal to this quantity, half times 9 times 3.5. So that's 4.5. So what we have essentially is that we have 3 times 4.5 times 3.5. This is the area of the entire triangle because these three pieces are of equal area, and this is, if you compute it, hand compute it, it is approximately 47, which is, the question was to find the nearest integer to this, so the nearest integer is 47. So that's the final answer. Keep on doing great mathematics, and we will meet in the next video. Thank you.